Okay, it says use the graphing utility, and certainly I'll do that. And Newton's method to find an approximate over here. Now, what I want to do is go through that cubic problem there is going to overtake the natural log at some point. And one way to do that is to look at a limit as x goes towards infinity. The ratio would be cube root of x over the natural log of x. And my claim is that cubic function, the top part, is going to overpower the bottom part. Now, certainly I may not know where it's going to happen, but my claim is it's going to overtake it. And that means that this will go towards infinity, that the top will overtake the bottom. So what I want to do, that's a claim. Let's see if we can do that. The limit, x goes to infinity. And I notice that both of those functions are going towards infinity. So I'm going to use L'Hopital's rule. So I'm going to write down x to the 1/3, and the bottom will write down natural log of x. I'm going to use L'Hopital's rule, and I'll write that down for a limit as x goes towards infinity. And if I took the derivative of the top, using L'Hopital's rule, it's going to be 1/3 x to the minus 2/3. I'm taking 1 from the exponent, and 1 from 1/3 minus 2/3. And the derivative of the natural log is just 1 over x. Right, let's simplify this. Limit x goes to infinity. I can multiply top and bottom by x. What do you get there? Well, you certainly get 3 in the bottom now. What do you get on top? X. Well, minus 2/3 and a 1 is going to be 1/3. Well, that goes towards infinity. All right? So I know that at some point that the natural log function is going to overtake, that the cubic function at some point is going to overtake the log function. And this is the log function over here at some point. Now, granted, this is the tough part. You know, when does that occur? It occurs somewhere, and that's why we use the graphing utility, by the way. And we also use Sage and Newton's method to figure out these points. But again, look at the graph. You're going to notice that we put a graph down here for you. And, you know, at this point, the green curve, by the way, that's the curve of the cube root function. And this pink curve over here is the natural log function. And at this point here, it overtakes. Now, by the way, in between, there's some behavior over here that we're looking for. When is that green curve below the pink curve? And again, the pink curve is the natural log. The green curve is the cube root of x. It's good to have pictures, by the way. Pictures certainly help. I also want to point out that software can find these points of intersection very easily. That's a point of intersection. And I went through that with the graph. But the bottom line is you're actually going to do Newton's method. And we just did that. Thank you.